This animation is intended to demonstrate production in a typical block caving mine. The design of the mine has been simplified for clarity, and the design and features present are by no means indicative of all block caving operations. Once caving has been initiated, the removal of ore can begin. LHDs, or load haul dump units, are used for this purpose. In effect, these are simply front-end loaders modified for underground use. The LHDs operating in the production level remove the ore that has fallen into the draw points and transport it to and then dump it into the ore passes. The ore travels down the ore passes through the influence of gravity and passes into the underground crusher stations. The crusher stations usually consist of large jaw crushers that reduce the average size of the material to that which can be more easily handled by the haulage and transport equipment. The ore may also be screened through a series of parallel bars called a grizzly. The grizzly prevents oversized material from passing and causing damage further in the ore transport process. After passing through the crushers, the ore is then transported to the surface. In some mines, this is through the use of underground locomotives and others via haulage trucks. In this example, the crushed ore is fed into a conveyor system. The conveyor then deposits the material into an ore bin next to the haulage shaft. Here, a skip in the shaft collects the ore, lifts it to the surface, and deposits it into a stockpile ready for milling at the processing plant. As the muck pile is drawn out via the draw points, an air gap develops between the muck pile top and the arch of unbroken ore above. When the arch reaches a critical size and area, the unbroken ore begins to fragment and cave onto the muck pile. As the caving of the ore continues up the ore body, the size of the air gap is controlled via the rate of muck pile removal at the draw points. Controlling the air gap size is done for several reasons, including mitigating effects of uncontrolled caving and air blasts that are caused by large failures in the overlying rock. Caving of the ore body may continue to the surface, where significant subsidence will result.